all for the invitation here. Coming from tech background and considering not a lot of people here are, from the tech, they are from public health and medical side. So I have kept my presentation, very on an abstract level so that everybody can understand. And again, I always start with my presentation by thanking Paul and World Technology Partners. And the reason is when I, proposed this project, I was at very initial stages. And, when you're in your initial stages of the idea and you get a small grant, that always boosts your confidence and it really validates your idea. So this is something, I will take with me, I think, throughout my life, because this is the first boost I got in my initial times of my career, I would say. So my work was on disfluencies in stuttered speech. And let's start by understanding what is stuttering. So, okay. Okay, can you see the slides moving?
Yes.
Okay. Okay. So stuttering is basically a disruption in the normal flow of speech. And we have all met such people who, when they speak, sometimes they repeat their words a lot or use a lot of filler words like ums and ahs in their speech, or sometimes they're not even able to speak, they would be like stuck, or in some cases they prolong on certain syllables. And these disfluencies, you can see these are basically the disfluency types: block, prolongation, sound repetition in stuttered speech. Now, this affects 1% of the population worldwide, making it up to 2 million people in Pakistan. Now, first, let's just understand the conventional approach through which speech language pathologists, they assess their patients. So they have to listen to the audio carefully, and then they have to identify these disfluency types in that audio. They have to count the number of times a person has stuttered, and then there are certain other parameters like frequency of stuttered words per minute that they have to calculate. Meanwhile, in the parallel, they have to observe these accessory behaviors as well. For example, some people, they grind their face a lot, or they may be anxious. So these are some accessory behaviors that they have to notice as well. And then finally, they're able to, the speech language pathologists, they are able to give the diagnosis. So this process per patient could be for around 1.5 hour, and and it also take a lot of cognitive effort to give the diagnosis. So the ultimate goal here is to have such an application that takes the audio as input, processes the results, and give you the report. But how is it possible? Well, it is very much possible through these deep learning models. They are basically AI models, abstractly. So what happens is that you give the audio as input, and these deep learning models, they basically learn these features by themselves, which contribute towards the output, and classify these disfluency types in the audio. Now, in my research, first thing, okay, these deep learning models, they are heavily dependent on the quality of the data. So in my research, that was the first thing, that the quality of the data set was not properly catered. Secondly, every application that we use should be resource efficient. For example, the mobile application we use, the websites we use, we prefer the ones that are fast, that are efficient. That means the technology is very resource efficient. So similarly, in these deep learning models, we have to make sure that they are as resource efficient as possible. Secondly, thirdly, the research gap was on such use cases where there are multiple disfluency types occurring in a single audio clip. For example, in a single audio clip, a person might uh, be prolonging certain words and using a lot of filler words. So these are two disfluency types occurring in the same window. So these were the use cases that we had to cater. So in my research, I worked on the data set, the data cleaning part, and pre-processing it, the audio speeches. Secondly, we designed a pipeline to create these multi-stuttered data sets for our model to actually learn these representations, because there was no such data set available. Thirdly, this is the proposed architecture. Um, let's not get into the technical details here. So just understand that we have some audio input, and this is all the process it goes through, and at the end it gives us the output. And in this case, we can have multiple disfluencies as output, which was the main focus of my research. Now, this is a small demo that I created, and the main thing you will see is that I uploaded the audio clip of 9 minutes, and it will process it in 11 seconds. And uh, once you have these disfluency types, basically through those disfluency types, their count, there are other parameters that you can easily calculate and come up with a dashboard like this. So all those R's that and the cognitive effort that a speech language pathologist had to put in, it's very much possible. Uh, it in a single click. Looking into the future, yes, we still need to work on the dataset part, bringing in more different dialects and languages to make for a broader applicability. The third point in which I'm personally very much interested in is to leverage the generative AI. By generative AI, I mean nowadays you all might be using ChatGPT, Meta AI in your WhatsApp, or with DeepSeek coming in, and these models are basically now going into the multimodality as well. So now they can understand the speech as well as text, and some models even the vision part, even the images as well. So now my next focus is to leverage this technology and get more insight into the stuttered speech, and make this system more accessible. Now, these are my great advisors. Dr. Simab has been my supervisor for this thesis. And from the business perspective, Sir Faisal has been a great advisor. And lastly, Ms. Sana Mukhtar, she is a speech language pathologist with over 13 years of experience, who really helped me with the domain knowledge and everything. So that's all from my side. If you guys are interested in the papers, I can share the link in the chat. And if you have any questions, please let me know.
Great. Thank you very much, Huma.